In this problem, we're asked to simplify the radical. We need to use a property of radical says that the square root of a times b, product, is equivalent to the product of the square root of the a factor and the square root of the b factor. We're going to use that rule forward and backwards throughout the radical chapter. Now, uh, and the rule for radicals is leave no perfect square underneath the radical. If we can take the square root of something, we need to extract it. So I'm going to separate this radical into two radicals based upon this rule on the right. And I want to put all squares in the first radical and the non-squares in the second radical. Well, if I look at 12, 12 factors into 4 times 3. 4 is a square, 3 is not. A to the fourth is a square by the law of exponents. Says when you multiply exponentials, you keep the base and add the powers. So if we can think of a to the fourth as a squared times a squared, that gives me back a to the fourth. Therefore, a to the fourth is a square. B to the seventh is not. If we just drop the power by 1 to an even number, so if we think of b to the sixth, b to the sixth is b cubed times b cubed. So b to the sixth is a square. 6 is not a square, but b to the sixth is by the definition of exponents. So I'm going to break b to the seventh up into b to the sixth times b. All the squares are into the first radical. If I take the square root, which would be 2a squared b cubed, and I'm left with the radical 3b. So I've left no perfect squares underneath the radical, and I've applied the law of radicals. Let's look at this problem where we're asked to fill in the blank. The square root of a product is the of the square roots. Well, we just did a problem. Let's see if we can figure out what the right answer. The square root of a product is the difference, the sum, the product, or the quotient of the square roots. Well, the square root of the product is the product of the square roots, is what we used in the previous problem. That is the correct answer. Let's read the problem. The radius of a sphere is given by the formula r equals the square root of s over 4 pi, where s is the surface area. If the surface area is 226 inches, what is the radius? Use 3.14 for pi and then round your answer to the nearest tenth of an inch. Well, I'm going to plug into the formula. R is equal to the square root of s, which is 226. I'm going to divide that by 4 times the pi value, which is 3.14. And I'm going to get out my calculator, turn it on. I'm going to put in the radical. So I have the radical in, and then I'm going to put 226 divided by, I'm going to use left-hand parentheses, 4 times 3.14 right-hand parentheses. And now I'm going to ask it to calculate. And let me show you what it looks like. I'm going to calculate, and I'm getting an answer of 4.241. We need to round it to one decimal place, so I'm going to say 4.2 is the correct answer. The diagram below shows the side view of a plan for a slanted roof. Find the unknown length, which is the hypotenuse of this triangle, in this roof plan. Express the answer as a simplified radical if the radicand is not a perfect square. All right, we have two sides of the triangle given, 5 feet and 7 feet, and the hypotenuse is the third side. According to the Pythagorean theorem, the hypotenuse is equal to the square root of the sum of each side squared. So I'm going to plug in the value of A, which is 5, square it. The value of B, which is 7, square it. We do the squaring before we add, so that's 25 plus 49. We add before we take the square root, that is going to be 74. 74 does not factor into a perfect square and a non-square. So therefore, this is our answer in simplified radical form.